given a how to convert stilbene into diphenyl acetylene. Okay. Now, whenever you want to convert an ene to an alkyne, the first step that you need to do is you need to create a dibromo product of it. Now, they have said stilbene. They have not said trans stilbene or a cis stilbene. Okay. For example, I have dealing with a trans stilbene. Okay, and we are adding Br2 in CCl4, so that is a reagent that is used for test for unsaturation. That means that whenever there is an ene or an ine compound, if you add a drop of bromine back, or you take Br2 in CCl4, Br2 is also a covalent compound, CCl4 is also a covalent compound, both are having dipole moment 0, so they are miscible, and the solution that will be formed would be having a straw color, okay, or it would be having a straw color. If you add trans stilbene to this, it would decolorize the solution. Now, what would be your products? If you have a trans compound and you are doing a EAR, means electrophilic addition reaction, the stereochemistry part of that is anti-addition. Now, the hint that I had given you, that whenever you add any halogen, which is X2, commonly we take Cl2, Br2 or I2. Okay, and if you take that in CCl4, they will undergo EAR, means electrophilic addition reaction, okay, which goes via a cyclic bromonium ion. Okay, so you can now imagine that this pi bond will attack one Br of the bromine molecule, okay, and that bromine will add as an electrophile. And if you cleave the bond, okay, so you're getting a cyclic bromonium ion. Now, the bromide ion can attack any of this. Now, let's think that we have already formed. Okay, you can put a triangle over here by removing the double bond, and at one of the vertex of the triangle, okay, leaving these two carbons. Okay, over here we will put a Br plus charge, which would be having a bond with this carbon and that carbon. Okay. Now, the Br minus that is generated in this reaction can attack any of these carbons, okay, of the cyclic bromonium ion. A simpler way of remembering this, as I had discussed before, is that whenever you have a trans compound and you make it undergo anti-addition, you will always end up getting a meso product. This is one way of representing the meso product. Now, if you draw the fissure of that, so this molecule is equivalent to that, and that we are representing by a three lines, okay, which means they are equivalent to each other. And as you could see that we are having both the bromos, which are on the same side, both the hydrogens are on the same side. At the top part we have phenyl, and the bottom part we have phenyl. Now you could imagine that if you pass a plane or line through this and that CC single bond carbon, then this molecule can be divided into two equal halves, which means it is a meso compound. Now, sometimes I keep telling my students is that whenever you have a trans compound and if it is undergoing anti-addition, you remember you will get a meso compound. Now, this is for people who are learning on the surface. Okay. Okay. But sometimes such kind of things can lead to oversimplification, which is not something we want. Now, here, instead of giving a Br2, I may give you a ICl or a IBr. Okay. Now, over here, this is an interhalogen compound. IBr is also an interhalogen compound. Or I could give you a nitrosyl chloride. Now, how do I decide among iodine and chlorine which one is the electrophile? Now, that we can decide using the concept that which is more electronegative. In an ICl, which is the interhalogen compound, the Cl is more electronegative. That's why we have put a delta minus charge over here, and for an I we have put a delta plus charge. Okay, so now this negative pi electron cloud is going to make an attack on this, which will subsequently lead to formation of a cyclic ionium ion, right? And a chloride will be cleaved off. Okay, just like we had discussed for the bromonium ion. Once the bromonium ion is formed, any of the carbons to which the bromine or the bromonium ion, I mean the Br plus is added, uh, the bromide can attack any of the carbons. Okay. Similarly over here, if this is the 2 carbon to which the I plus is added, the chloride can attack any of these carbons. So that would mean that we can have a DL pair. So 50% of D and 50% of L. That means as a whole, this mixture will be a racemic mixture. Okay. Now, having discussed this problem, I'll give you a problem which is already there. Where? In solvent pride. Okay. Better to go for the 9th or the 11th edition. A question very similar to this may have come in advance or may have come in a KVPY. I do not remember exactly, but it is there. You have been given a cis-butene, you have been given Br2, and then they have mentioned that NaCl equals. Okay. There's a lot of story behind this. I'm discussing that part. Now, whenever you have a Br2 inside aqueous medium, that means what? It will undergo disproportionation reaction, leading to formation of what? HOBr plus HBr. Okay. So, if we think that a cyclic bromonium ion is formed in this case, okay, and once it is formed from the Br2, we have a bromide ion inside the solution. Apart from that, we have a chloride ion inside the solution. Apart from that, since Br2 will react with water to give you HOBr, which is hyperbromous acid, alright, and HBr. So what are the options that you have as a nucleophile once the cyclic bromonium cation is formed? You have a hydroxide, you have a chloride, you have a bromide. Okay, when the hydroxide attacks, it is what? It is a bromohydrin that will be formed as a product. For that, we are going to have D and L pair. So that is accounting for 2 molecules or stereoisomers. If the cyclic bromonium cation is attacked by the chloride, then also it will be producing a DL pair. Now, If you take the third option, which is the bromide ion, then that also will give you a DL pair. Okay, so we can now say that we're going to have 6 products. Hmm? 6 stereo isomers. Thank you for listening.